Welcome, students. In this session, we will first discuss Labyrinth Seals, which are widely used in high-speed rotating machinery, such as turbochargers and auxiliary steam turbines. Labyrinth seals are designed not to completely block the flow, but to minimize leakage by offering a complex, zigzag pathway for the gas to pass through. This makes the flow more difficult and slows down the leakage significantly. Let's discuss how it works. The working principle of labyrinth seals is based on pressure reduction and energy loss. As the gas tries to escape, it is forced to pass through narrow clearances and multiple turns. This creates turbulence, eddy currents, rapid change in direction of flow. Because of these factors, the kinetic energy of the gas is lost, resulting in a gradual reduction of pressure. Eventually, the gas loses energy and its ability to escape is reduced. This method is very effective for sealing high-speed rotating shafts. Let us look at key characteristics of labyrinth seals. They do not require direct contact between the shaft and the seal, suitable for high-speed applications where contact seals would wear rapidly. Mostly used for gas sealing, especially in turbines and turbochargers. They work purely based on the principle of energy dissipation, not friction. Thus, labyrinth seals are ideal for applications where minimum wear, high speed, and low leakage are required. Now, let us move to PTFE seals, also commonly known as Teflon seals. PTFE is one of the most widely used sealing materials due to its chemical resistance, low friction, and high temperature capability. However, PTFE has one limitation: it lacks natural resilience. That means it cannot fully return to its original shape after compression. So, in many applications, energizers such as springs or elastomer rings are added to ensure effective sealing force. Material enhancement. To improve toughness and flexibility, PTFE is often reinforced with fillers such as short glass fiber, bronze particles, carbon graphite, or a combination of materials. These fillers improve strength where resistance, dimensional stability, and thermal conductivity, making PTFE suitable for demanding applications. Advantages of PTFE seals. PTFE has multiple advantages. Resistant to almost all industrial chemicals. Can withstand temperatures up to more than 500 degrees F. Excellent low temperature flexibility. Very low friction due to its non-stick surface. Suitable for dynamic sealing in reciprocating motion. Because of these properties, PTFE is widely used in severe conditions where other materials may fail. One of the most important uses of PTFE is in glide seals, especially in hydraulic and pneumatic cylinders. Seal types used. For hydraulic applications RA, RB, RC, PA, PB, PC. For pneumatic applications PD type. For edge sealing, a wiper ring may be used with the seal. These seals are commonly found in machine tools, industrial control systems, pneumatic and hydraulic drives, automotive and vehicle systems. They operate with low friction, low wear, and provide a long service life. Why PTFE glide seals are preferred. PTFE glide seals are ideal when systems require smooth, stick-slip-free motion and long-term reliability. They perform well under high pressure, high temperature, high sliding speed. They are also suitable for precise positioning, such as in automation systems. In harsh environments like marine, chemical, thermal power, or dusty industrial conditions, PTFE glide seals provide excellent protection and stability. The main performance features include excellent low-friction gliding, high wear resistance, chemical resistance to aggressive fluids, high extrusion resistance, good thermal conductivity, easy to install and available in many sizes. These characteristics make PTFE an ideal sealing material across a wide range of industries. Let's gauge some of its application and its purpose. It is used in hydraulic cylinders for its low friction and low breakout force. In pneumatic cylinders, it provides smooth motion and no stick slip. In plungers, it is used for its reliable sealing with low wear. In corrosive environments, it gives chemical resistance. At high temperature operations, it shows thermal stability. In precision control systems, it gives accurate motion and tight sealing. To conclude this session, Labyrinth seals are best suited for gas sealing in high-speed rotating machinery, while PTFE seals are more suitable for high-temperature, chemically aggressive, and dynamic applications. Understanding the characteristics of each sealing type helps us select the correct seal for pumps, turbines, compressors, hydraulic equipment, and various industrial systems. Thank you. Have a great day.